Understanding the behavior of rational functions simplifies a great deal of working with understanding with them. In this case, we're going to find the vertical asymptote, the wholes, y-intercept, and horizontal asymptote of these two functions. Vertical asymptotes happen when the denominator of the function equals 0. In this case, when we have 1 over x minus 2, the denominator, x minus 2, equals 0 when x equals 2. Therefore, we can see that at the asymptote, at x equal 2, we have a vertical asymptote. This means the function will look something like this. Wholes happen when we get a 0 over 0 situation. In this case, we have 1 over 0. So there is no hole here. It's not defined right here, but it's not a hole either. The y-intercept is where x equals 0. So if we can plug x equals 0 into this function, 1 over 0 minus 2 equals negative 2. The x-intercept, the y-intercept is y equals negative 2. Right there. The horizontal asymptote. The horizontal asymptote for this function will be 0. As x becomes a very large number, a very large positive number or a very large negative number, we are dividing 1 by a very large number. That 1 over a very large number is a very small number. The larger x becomes, the smaller this fraction becomes. This fraction will become closer and closer to 0. It will never actually reach it, but it will get closer and closer, which is what an asymptote is. So for wholes, we're going to write NA, not applicable, no holes. Y-intercept, x minus 2. Horizontal asymptote is y equals 0. Now, for a slightly more complicated function, we use 2x minus 3 over 2x. In this case, we have a vertical asymptote because we can set the denominator equal to 0. The denominator equals 0 when x equals 0, and only then. So in this case, we will write x equals 0. For the only time we have a hole is when we have a 0 over 0 situation. So if this only equals 0 when x equals 0, then we can plug 0 into here. We get negative 3 over 0. So we can conclude there are no holes for this function. Not applicable. For the y-intercept, we set x equals 0 and plug it into this function. We get 2 times 0 minus 3 over 0. 2 times 0. That, since you cannot divide by 0, that is undefined. This is because this is where our asymptote is. This function will look something like this. And so we have no y-intercept because it never actually touches this line because it is an asymptote there. The horizontal asymptote. This needs to be, we need to pay attention to this. Here we want to know what does this function become as x becomes a very, very large number. In this case, we have 2x minus a number over 2x. As 2x becomes very, very large, much larger than 3, it'll become so large we can basically ignore the 3, because x will grow faster than the negative 3 will. We can put 100 here, 1,000,000 in here, 1,000,000,000, until this just becomes inconsequential. In other words, it gets close to x over x, which is 1. So this function, as it becomes very, very large, or as x becomes very, very large negative, the function approaches, but there actually equals, y equals 1. Hence we say that is the horizontal asymptote. Y equals 1.